Hello everyone, welcome back to our channel, and today we are going to learn about mathematical logics. Okay, before we start, we need to introduce ourselves first, and this is our team. This is my partner. Her name is Putu Candradewi, with the last digit number is 002 from GA class, and this is me, Gede Candradewi, with the last digit number 003 from 3A class 2. Okay, before we really start the lesson, it's better to do a brainstorming before to build our motivation for study. And this is the quotes of the day. Okay, we are what we repeatedly do. Excellent then is not an act, but a habit. This beautiful quote is from Aristotle. So, if you want to know more about math or learn about math, you just need to practice and practice and practice every day. So, it is about habit. Okay. Next, first we are going to learn about proposition. First, we are going to talk about definition of propositions. Propositions are sentences that contain true or false values but not both. The statement is expressed in a lowercase letters such as P, Q, R, and etc. There are two bases for determining the truth value of a proposition, namely empirical basis and non-empirical basis. So, empirical basis, that is the truth value, is determined by observation at a certain moment. For example, my sister has long hair. And non-empirical basis, that is the truth value is determined according to certain rules or laws. For example, the sum of angles in a triangle is 180 degrees. Okay, next we are going to talk about negation of proposition. Negation of a proposition is a proposition that denies the original statement. The negation is denoted negacy P, and it is read as not P. So this is symbol, and we can read not P. Yeah, for the example, P that go to the market, and negation of P that doesn't go to the market. Okay. Next, lesson 2, quantifiers proposition. Okay, next we have the definition of quantifiers proposition. Quantifiers proposition is a statement that contains a measure of quantity. There are two kinds of quantifier, namely 1. Universal quantifier, and second, existential quantifier. Okay. Universal quantifier states all and each. This universal quantifier is denoted by this sign. We can read for all or for every. For example, for all x element r, comma, x square more than 0. Read for every x member of the real number, then x square more than 0 at least. So, second, existential quantifier state that there is some, partly, and excess. The existential quantifier is denoted by this sign. We can read as there is some, partly, and excess. For example, some fish breathe with lungs. Okay, next. Okay, The negation of quantiferous proposition. Negation of the universal proposition is the existential quantor, and conversely, the negation of the existential proposition is the universal quantor. For example, V. All fish breathe with gills. Negation of V. There are fish that not breathe with gills.
Now we will talk about propositional calculus. Definition of propositional calculus. First, we have the conjunction. Conjunction are compound statements with the conjunction and, which are denoted by like this. Pronouns P and Q. Second, disjunction. Disjunction are compound statements with the conjunction or, which are denoted by like this. Pronoun P or Q. Third, implication. Implication are combined statements with the conjunction if then, which are denoted by like this. Pronouns if P then Q. Last one, we have the implication. Equivalent are combined statements the conjunction if and, which are denoted by like this. Pronoun P if and only if Q. The third table of propositional calculus. First, we have the third table of conjunction. Second, we have the third table of disjunction. Third, we have the third table of implication. And the last one, we have the third table of B implication. Now, we will talk about converse, inverse, and contraposition. First, if Q, then P is called converse from the first implication. Second, if negation P, then negation Q is called inverse from the first implication. Third, if negation Q, then negation P is called contraposition of the first implication. Example, negation from 5 plus 2 equal to 8 and my brother has a upgrade class is 5 plus 2 not equal 8, or my brother has not an upgrade class. Negation of propositional calculus. First, we have negation conjunction like this. Second, negation disjunction like this. Third, negation implication like this. Last one, we have negation B implication like this. Now, we will talk about argument. Definition of argument. Argument is a series of statements that have a concluding expression. An argument consists of two groups of statements, namely the premise group and the conclusion group. An argument said to be valid if for all possible truths use the premise get the correct conclusion as well. Basis of argument. First, we will have opponent. If P then Q is right, valuable, and if P is right, the Q is right. Second, tollen. If P then Q is right, valuable, and if Q is wrong, the P is wrong. Last one, we have syllogism. If P then Q and if Q then R, Is right valuable? So, if P then R is right. Example, premise 1. If it's sick, then mother will take the medicine. Premise 2. Mother is sick. So, conclusion is mother will take the medicine.
Okay, thank you so much for watching and hope you can enjoy the video. See you next time. Bye bye.